Okay, so good afternoon to all. Good evening to all. So today we will do the common emitter configuration experiments, and we will verify the diagrams, the characteristics which I had already shown you. I got this one. So we will verify these characteristics. Okay, so did you get the assignment on Google Classroom? Good evening. Did you get the assignment on Google Classroom? Okay. So try to solve it. Two or some problems are a bit advanced. You have to think a little bit, and if you have problems you can go through the lectures once again. All are there in the YouTube or the notes or books, or you can ask. Okay, so if you understood those characteristics which I discussed in the last class, you should be able to solve. One problem is related to voltage divider bias, which I have not taught yet. Okay, so next week probably we will do it. Hello. Good evening. Okay, so should we start? Today Nitai sir will also join me in the lab. Okay. So first, what we will follow the usual procedures. Let us open this basic electronics lab. Okay. Then list of experiments, and then this one, number 10, BJT common emitter characteristics. And probably this would be the last virtual lab because I don't have any other topic. You see here, diode is done, Zener diode is done, common base is done, so only this common emitter is remaining. The other things, BJTC, amplifier, RC frequency response, these things, this will be taught in the higher semesters. So common emitter, we click. Okay. So we come to the simulation. So there are two characteristics. One is the input characteristics and the output characteristics. Okay. So we do the input one first. Just to recall, the input characteristics like this. Once again, we see that VCE is 1 volt, 10 volt, 20 volt. Unfortunately, so in order to see any difference, we need to make this VCE up to 10 volts, 1 to 10. But from this setup, I don't think you can make VCE 10 volt. Is it possible? This one. Yes, 10 volt. Okay, we can do. So for 10 volt, 2.95. There is a difference. Okay, very good. Good evening. So what we are going to do? We are going to take 5 readings. I am writing it for you. 2, 4, 6, 8, 10. So this would be our VCE values. Okay. And what we are doing, we are changing the base emitter voltage, this one, and we will note the corresponding base current. Note that the base current is in microamperes. Right? Have you all of you opened this experiment? All of you have opened the experiment? So tell me when all of you are ready, we will start. Okay? Okay, I am waiting. Open this page, the one you can see on your screens. So all of you are ready now? Okay, good. So check the values of VC I have written 2, 4, 6, 8, 10 volt, 5 values, okay. And we will change the base emitter voltage and we will load the base current. Since it is a forward bias, basically this base emitter is forward bias, so we will take values of 0.1, 0.2, 0.3 up to 1 volt, okay, for each value of VC. Fine. So let us start. So let's make VC is 2 volt. We can vary this RH2 and make it 2 volt. All of you have met. Now we will change RH1 and make it 0.1 volt, okay. Note the value of IB and IC and add to table. Then 0.2 add to table, 0.3 add to table, 0.4 add to table, 0.5 add to table, 0.6 add to table, 0.7 add to table, 0.8, 0.9 add to table, then 1 volt add to table. All of you have done up to 1 volt. Note that VC is 2 volts is given here, right? All of you have done 10, those taken 10 readings, 0.1, 0.2 up to 1 volt this way. We are recording, yes, exactly. We are recording. You are recording VB and IB for a given value of VC. Yes, please sorry. Okay, is it back now? Are we back now? Hello? Are we back now? Okay, good. So stable. So take it the 10 readings. These values are okay. All of you are getting the similar readings in your desktop or laptop. All of you are getting similar readings. So we plot. Get a curve like this. Okay, now you are requested to copy these values on a piece of paper or take a photo of this screen, whatever, take a screenshot, whatever you are comfortable with. So please do that. Either note down the values or take a screenshot or take a photo, whatever you are comfortable with. And when you are done, tell me. Yes, I cannot help it. That's a net problem. I know it is buffering. So you have noted the values. Okay, so today there is some problem. Hello. Okay, so today there is some problem. Let us try whatever. So you need to take 10 values of VB. Check the comments. You need to take 10 values of VB for values I have given. And so this value for 2 volts have you taken the values. So now just clear the readings and make this 4 volts. Change RH to make it 4 volts. Right. Then we repeat the same steps. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, right? Again plot. Check the readings. Okay, let me try something else then. Just wait. If this doesn't work, we have to call off the class. So taken for 4 volts. Okay, note the values, clear this off, and repeat the process for 6 volts. Let us repeat the process for 6 volts. Hello. Hello. Okay, we will try one last time. If this doesn't work, we have to force to call off. We will do this is one last time. We will try. If it works, is good. Otherwise, we have no other choice to call off. How much you have done so far? By the way, this is for the input characteristics. Okay, as you can see here, it's for the input characteristics. How much you have done so far? This works is good. Otherwise, we have to force to call off. It's very difficult. No, I think now it is working fine. How much you have done? 6 volts up to done. 6 volts I have. So it has finished 6 volts. Fine. So take the values and let us plot. Right? Note the values. Take a screenshot. Write it on a pen or paper. What happened? Yeah, so we'll note the value, write it on a piece of paper.